Hello everyone. In this video, I will show you the Python UDF feature of IBM Db2. It's a feature that is available in Db2 on the Linux platforms. Python UDF feature allows one to deploy a trained Python model on the Db2 server and use this model to generate predictions on data stored on a Db2 database. On top of that, someone can write a SQL query to generate predictions using the Python model via Db2. This greatly simplifies the integration efforts of Python models with the end applications. In this demo, I will show you how simple it is to deploy a Python model on IBM Db2 and use it via SQL. I will show you a complete workflow of Python model development using data from a Db2 database, then deploying this trained Python model on Db2 and registering this model with Db2 as a Python user-defined function and using this user-defined function via SQL to generate predictions. In this demo, I will be creating a supervised machine learning model. In this example use case, I will create a classification model. In this example, I will use a dataset of historical flights in the US. This data is stored in a Db2 database. Each record corresponds to a historical flight in the US, and for each flight, we have information such as its origin airport, its destination, its flying time, and such. Along with each flight record, we also have a indicator whether this flight had arrived on time or was delayed. Using this dataset, I will train a classification model to predict whether a flight would arrive on time or delayed. Here is the workflow. The data is stored in a Db2 database. I will read this data from Db2 into a Python Jupyter notebook. After loading it, I'll do some exploration of the data and apply some transformation on the data and train a model on the transformed data. And after training the model, I will export the trained model and deploy this on Db2 using a Python user-defined function. And finally, I will use this deployed model to generate predictions on a set of test flights to see whether what the model predicts on the arrival status of. This workflow consists of 10 steps. Let me take you through these steps. As I'm talking, I will run the code live and show you the result. All my steps, I will demonstrate this workflow via this Jupyter notebook. In step 1, I'm importing some required Python libraries that I will use in this notebook. So I'm not going to explain what these libraries are, but these are fairly standard, such as pandas, scikit-learn, joblib, and numpy are the main libraries that I'll be using. Next, I will use Db2 magic commands for executing SQL against Db2. Those of you who are not familiar with Db2 magic commands, it's a Db2's extension for Jupyter Notebook. It's quite handy because what it allows you to do is embed SQL statement directly in your Python notebook and run them inside of the notebook cell without writing extraneous code or additional code for making connection to Db2 and for preparing your SQL statements and running them with Db2. Db2 magic commands behind the scene handles all this additional coding for you. This code block will download Db2 magic commands and enable this as an extension on this notebook. In step 3, I will connect to the Db2 database where my training data set is stored, and then I will read the data set from the DB2 table into this notebook. Let's do this. Here I have just successfully connected to the DB2 database. Now I am going to read the records from this table in DB2, and the name of this table is flights_train. This code block will read this table and show us 5 sample records. Let's interpret the output. The database, the data that we have read here, it has the information about 160,000 flights, and for each flight we have 19 columns, and the table has 19 columns. Since there are too many columns, I'm showing you the important columns from this data set. As you can see, each row here represents information about a historical flight. If you have noticed, all these columns, months, days of week, these are all the columns that will be used as features for our ML model. And also there is a column called flight status, which takes a value of 1 and 0. 1 represent that the flight was delayed, and 0 represent the flight arrived on time. This flight status column will use as the target or label for training of the classification model. In supervised machine learning model, the model is trained with two kinds of information with labeled examples, where each example has a set of features and also a target column, a target value, and then all these combinations of input features and the target are passed to a learning algorithm, and then learning algorithm comes up with a way to map this input to the output. Once the learning algorithm has seen many such examples, labeled examples, then and it learns to predict the output from the input. Next time, once the model has been trained, now you can only provide the input to this trained model, and the model will produce an output. Next, I'm also splitting this data set, which has 160,000 flight records, into two partitions, train and test, where 80% of the records goes to the train partition and the remaining 20% goes to the test partitions. Why am I splitting the data set into train and test? So that I can train model on using this 80% of the records, and then evaluate this train model using this test set. It's more like testing the quality of this model. So far, what I have done, I have completed step 4. I have divided the data set into train and test partitions. Let's look into this. Here I am doing this split. Then I am also defining what are the input columns or input features for my model, and also what is the label column for the model that will be trained. Next step, I am defining the machine learning pipeline. The machine learning pipeline consists of any data transformation steps, and finally the algorithm that I will use for training of the model, the learning algorithm. In my case, I kept it relatively simple. I have some pre-processing steps for numerical columns. What basically it does, whenever there is any missing values found in any of the numeric columns in the data set, you will replace those missing values with 0. Because most machine learning algorithms cannot work with missing values. So you need an approach to take care of the missing values. Next, I am similarly defining a strategy to deal with missing values in the non-numeric column or categorical column. So basically I am telling, whenever a missing value is found, replace this with the most frequent value in that column. And then I am combining both transformation steps into a single data preprocessing pipeline. Finally, I am chaining all the preprocessing logics, those transformation steps, into a final estimator or learning algorithm, logistic regression. In this sample, I'm using logistic regression, but you can use more sophisticated algorithm right here, such as gradient boosting trees or XGBoost or neural network. Now, at this point, I have defined the training pipeline or ML pipeline. I have not yet trained the model, which will be in the next step. Next, I will define this model using this. I will train the model using the defined pipeline, the ML pipeline I have defined in the previous step, and evaluate this trained model on the test partition that I set aside in step 4. I have trained the model using 80% of the training records, and then I have evaluated the trained model using 20% of the test records, and I can see the test accuracy of this model is 87.45%. It also prints out the pipeline, which I have already explained, the data pre-processing steps, and finally the learning algorithm that is used. At this point, we have a model trained. The model is sitting in memory. We now need to export this model from memory to the disk and then integrate with DB2. Next step, I am exporting the train pipeline from memory to disk, and also I am defining a Python user-defined function in a separate Python script. This is the user-defined function. You can leave most of the code as is for this batch prediction, but when using a defining user-defined function, you need to provide a path to the train pipeline. Remember that in the previous step, I have saved the train model from memory into disk. I also need to make this train pipeline available on the DB2 server and provide it path in the definition of the UDF, so that UDF knows where the model is located, so that it can be loaded into memory as needed and used for inferencing. And also I need to define the model features, and rest of the code can remain as is. What this code is doing, it will receive as input a list of records, the flights records, and then during execution it will create a data frame using all these records, generate prediction using that model, and return all these predictions along with the input features to the caller or whoever has called this UDF. As you can see here, there is a load command. It loads the model from disk to memory. It also creates a list, empty list, and then it collects everything, and then it loads all the records, all the scoring input records, input flights into this list, and create a data frame out of this list and send this data frame to the train pipeline, and then pipeline, which is basically the train machine learning model, along with the pre-processing step, it will generate the predictions. Now these predictions are combined with the input feature and returned as output to the caller of this UDF. And we will see this. If you have not grasped all of this, don't worry, you will soon see the example execution of this UDF. Next step, register this Python UDF with DB2. In the next step, I have a SQL statement that will register this new UDF with DB2, so that it can be invoked via SQL. Here is the syntax for creating this UDF. These are fairly standard, this create or replace function. Then give a name to the UDF. In this example, I am giving it this UDF a name, my UDF underscore LR, and I am declaring the data types of all the input features, and also I am saying what this UDF will return. This UDF will return all the input values that it has received, plus adding the predictions from the model. Give a path to the function, the UDF function that we have defined in this separate file. Let's register this UDF. Now this UDF is registered with DB2, and it can be used for generating predictions on new records. Here is a SQL that I'm going to use for generating predictions for a set of test flights. These test flights are separate from the test flight that I had created in this notebook. This is a separate table. This is separate from the flights underscore train, that 160,000 flight records that I had brought into this notebook for training of the model. This is separate. These flights are coming from a separate table. If you remember that we loaded the training data set from a table called flights underscore train, but this is coming from a different table, flights underscore test. I am now calling this UDF, which I registered in the previous step, my underscore LR. I am passing the list of records from this table. I will execute this. Next I am executing this, and then finally I will show you the results of execution. What this cell is doing, it is executing this UDF by passing a set of input records for which we want to generate the flight, or we want to predict the flight status. Here is the SQL, and for invoking this UDF with a set of new records or test records, and then this block of code executes this UDF and brings the output from execution to this new data frame, and where and then we are printing here the output from this from the UDF execution result. As you can see, now we have a set of sample records where we can see the flight status predictions. As you can see, these predictions are actually generated by the Python model that we have deployed on Db2. Thanks for watching.